Set theory and probability. Set theory is important in mathematics. A set is really a collection of objects, and we find set theory to be very useful as we study probability. We're going to start with some terminology. A set is a collection of elements. An element is an object in a set. We normally name sets with a capital letter, and we use curly brackets or curly braces for set notation. The example that we're giving you, the capital letter A, set A, is equal to, and this is a set with 4 elements in it. The elements are the numbers 1, 3, 5, and 7 that are separated with commas. The empty set or null set is a set with no elements in it. The notation we use for the empty set is either the circle with a line through it that you see, or just a set of empty curly braces, and we don't put anything inside. That represents that the set in discussion has no elements. A subset is a set within a set. There are 3 notations that we can use for subset. Strict subset is just that what looks like a C. Subset or equal to has the equal to sign underneath it, or not a subset. An example of a subset, we have to come up with B given A, the set with 4 elements, 1, 3, 5, and 7. And we're told that since every element in B is an element in A, we can say that B is a subset of A. So there's a bunch of different options that you could put down for B. I happen to use 3 and 7. B is definitely a subset of A if the elements 3 and 7 were in set B. Here's another example. Same set A. This time, come up with a subset or a set C that is not a subset of A. And you can come up with anything for C as long as the elements in C are not in A. Even though the number 1 is an element in A, the number 2 is not an element in A, therefore C is not a subset of A. Now we'll go on to intersection of 2 sets, and they are all of the intersection are all of the elements in both sets. The notation for intersection is this upside down U. I'm giving you set A and set C here, and I'm asking you for the intersection of the 2 sets. Is there 1 or more elements that appear in both sets? Just the number 7. The union of 2 sets is a set of all elements that are in both sets. The notation for union is just this U. And here again is set A and set C, and this time we're asking you for the union of A and C. And the union of A and C would be all of the elements from both sets A and set C, but we don't duplicate the number 7. So A union C looks like this. The complement of a set is the set of all numbers not in the set, and we use 3 notations for complement. A with the subscript of C is a very common one. We can also say A prime or A naught with the bar above the A. So we're going to be talking about universal sets. And a universal set is given the first 9 positive integers. Set A is given as the numbers 1, 3, 5, and 7, and we're asking for the complement of A. In other words, what numbers are in the universal set but are not in set A? And that would be 2, 4, 6, 8, and 9. Let's get some practice working with sets. We have set A and set B. Both sets have 5 elements in them. We're asking for the sum of all elements in A union B. To solve this problem, we really want to think about A union B. Just because set A and set B each had 5 elements does not mean that A union B will have 10 elements. Because as you can see, the number 20 and the number 22 is shared by both sets. So when we consider A union B, we're only going to list 20 and 22 one time. Now when we add all of these numbers together, we get 89, which is the sum of all of the elements in A union B. So here we have set A has 5 elements. There are 3 numbers, 1, 2, and 3, and 2 unknown elements, which we'll call variables A and B, lowercase. Set B has 3 elements, 3, 15, and 21. Notice the number 3 is shared by both sets. If A union B equals, and they give us all of the elements in A union B, we're asking you for the value of A plus B. So what you want to do is consider A union B. Are there any elements in A union B that we do not see in set A or set B? I believe there are 2 elements, 6 and 10. So those 2 elements must be the variables A and B. And when I add them together, I get 16. All right, here's set A and set B again. Again, both have 5 elements. The numbers 20 and 22 are shared in both sets. What's the sum of all elements in A intersect B? A intersect B are those 2 numbers, 20 and 22, that both sets share. The sum of those numbers are 42. Let's look at the universal set that has 6 elements in it. And there's a subset A with 8 and 11 as its elements. What is the sum of all elements in the set complement of A? All right, so let's think about the complement of A. That is numbers that are outside of set A but still in the universal set. So here's my complement, and it's asking me for the sum of these elements. So I'm just going to add them together and get 44. Consider the universal set U equals X such that X is a positive integer less than 33. So think about all of the positive integers less than 33. So that would be 1, 2, 3, 4, etc., right? Going all the way up to 32. Now it says A is a subset of U. But instead of telling us about set A, they're telling us about the complement of A. The complement of A is quite a large set, isn't it? It is made up of positive integers less than 30. So let's think about the complement of A. And these are numbers that are in the universal set but not in set A. And I stopped at 29 because it said positive integers less than 30. So what is the sum of the elements in set A? Well, let's figure out what's in set A. What's in set A is in the universal set, not including the complement. So let's get rid of the numbers 1 through 29, and what's left over is set A. And when we add those together, we get 93. So that was a little bit about set theory.